Hi, and welcome to College Algebra 6.5. Today we're going to talk about systems of inequalities. So, the only difference today is we're going to have some inequalities instead of the equal sign. So, recall that when we graph these, you create a bunch of situations. So, the things to know with the graph is a three-step process. I need to recognize whether my inequality has the less than or equal to, greater than or equal to. Because if it does, it's going to have a solid line. If it doesn't, if it's less than or greater than, your line will be dotted. The reason the difference is because the equal to means points along the line are solutions. And then when I graph these, again, just like normal, we want to get y by itself, and we typically graph it as just the equation. For example, I would graph the equation y equals x plus 2. So, first step, graph the y equals x plus 2. Second, determine whether it's a solid or a dashed line. This would naturally have a solid line. The third step is we need to figure out shading. So, often what you do is pick some test coordinate that's not on the line. Here I've provided a couple. The only one which would be bad is -5, -3, because it's along the coordinate or along the equation. So if I pick any one of the other ones, so let's say we pick this one, 0, 3, we can plug 0, 3 in as our test. So I'm going to plug it into our inequality. So if I do that, I would get 3 less than or equal to 0 plus 2, because this goes in for the x, this goes in for the y. We get 3 is greater than or equal to 2, which is a true statement. So, because it's true, I would shade with the coordinate. So, this coordinate is to the up and to the left of my line. So, I would shade up here along with that coordinate. Let's say I picked a different one, such as, 0, 0. 0, 0 is often a really good coordinate to use. So, let's say I'm going to test that. So I get 0 greater than or equal to 0 plus 2. So 0 plus 2 is 2, so I get 0 is greater than or equal to 2, which is false. So I would shade away from this coordinate. So this coordinate is down and to the right. So I wouldn't shade where the coordinate is. I would shade everywhere else in the line, so up and to the left. Now notice, no matter which coordinate I picked, I shaded the same location, which is awesome. Okay. So every single thing in that is that shaded region, and the only major differences is, for example, this one doesn't have the equal to, so it would be a dotted line because the point on the line would not be included. So graph each inequality. Now, if we have multiple, we graph each individually, and we really look at for the overlap. So, first, let's say a couple equations. We have y is greater than or equal to 0. So y is greater than, I would just graph y equals 0, which would be a horizontal line. And it says equal to, so it's going to be solid. We have x equals 0, so I'd graph x equals 0. Again, equal to, so it's going to be solid, and that'd be a vertical line. And then we have 2x plus y is less than 10. I can subtract 2x from both sides. So I would graph the equation, or have the inequality y is less than 2x plus 10. So I could graph negative 2x plus 10. So that would have an intercept of 10, and it would have a negative 2 slope. And that would be a dotted line because it doesn't have the equal to for the inequality. Now, I have all of my inequalities done. All I have to determine now is the shading. So I need to look at each of these things. This first one, y is greater than or equal to 0. Well, what y values would be bigger than 0? The positive ones. And all the y positives would be up here vertically. So what I like to do is I like to draw a little arrow at the end of my equation or inequality, indicating that if I were just shading the purple, if I was just doing purple, that's where my shading would go. Same thing with x is greater than or equal to 0. That would be an arrow to the right because all these x values are positive. So again, if I were just shading that one, my graph would be shaded over here. And the other one I need to worry about is this blue one here. Well, I could just pick some coordinate, so it's either above or above up here or below. So let's pick 1, 1 and test it. So 1 less than negative 2 times 1 plus 10. Negative 2 times 1 is negative 2 plus 10 is 8. 1 less than 8 is a true statement. So I would shade below it normally. Normally I would shade all of this stuff here. So if I'm looking at each of the individual shadings, I would shade to the right for the red line. I would shade down and away for the blue line, and I would shade, up for the purple. So where do all three of those shades overlap? Well, they would all overlap inside the triangle region. So the only shading I have to do is where every single shade is overlapped. So right in here. Let's try another one. We have y is greater than or equal to x squared plus 3. So that would look something like this with the intercept of 3, and it's a parabolic shape. It's got the equal to, so it's going to have solid lines, and it's going to look something like that. That would be y equals x squared plus 3. When in doubt, I can always type in my calculator to get good coordinates. Over here in blue, couple things. I could recognize that this is the equation of a circle, which follows x squared plus y squared equals r squared. So I could tell that my r would equal 4, which would just be a radius. So I'd go 4 in each direction, and I could turn that into a circle. Because it doesn't have the equal to, that'd be a dotted line. So it would look something like that. If you didn't recognize that, I could still solve for y. So I could do x squared plus y squared equals 16 minus x squared y squared equals 16 minus x squared, square root, square root. Now the thing is, we're square rooting, so I would get plus and minus the square root of 16 minus x squared. Well, how do I account for this? Well, because I'm doing inequalities, I could leave the inequality with the original, 16 minus x squared, and I could flip the inequality with the negative sign. Now, how would that look? Well, this one would be right here, and this one would be right here. And together they create the exact same blue shape. And then I could either do all three inequalities or just the two that I started with. So, shading. This one says greater than or equal to. It'll actually would be shaded inside the parabola. This blue one says less than. I promise you, for the sake of time, it will be shaded inside. So I need to shade inside the blue circle and also inside the parabola. So I would get something like this shading right here, this little section. If we wanted to quickly prove that, for example, I'm going to use the coordinate 0, 0 for both. So if I plug in 0 into this one, I'd get 0 greater than or equal to 3, which is false. Now, if I'm looking at where 0, 0 is in comparison to the red parabola, it's on the outside. So if it was true, I'd shade all this stuff. But because it isn't true, I would shade inside the parabola. And if I did the exact same thing in blue here, 0 squared plus 0 squared less than 16. I get 0 less than 16, which is true. I would shade inside the circle, which would be all this stuff. So, what region is inside the circle and also inside the parabola? This little chunk right here I told you earlier. Thank you for listening, and I hope you have a wonderful day.